Hey everyone, this is the walkthrough for the Google Cloud portion of Cloudblock. We'll start from the GitHub page for the project and go to the GCP directory. There it is. Looking at the prerequisites or the requirements, you should already have a Google Cloud account. You should have that before we continue, and you should have already followed the previous step-by-step video, which goes over installing Windows subsystem Linux and installing Terraform, Git, and creating a SSH key pair. Let's scroll down to the Google Cloud specific instructions. First thing we need to do is open PowerShell and start Windows subsystem Linux. I'll do that from start. Look for the word power, there's PowerShell, and type in WSL and CD to my home directory. We need to add the Google Cloud repository. It's a long line, so make sure you grab the whole thing. And you'll be prompted for your password. This is the same password you created when you set up Windows subsystem Linux. Done. Scroll back to the left, and we need to install the prerequisite packages before we install the CLI tool. This should be pretty quick because I've already installed this package. Another long command, make sure you grab the whole thing. We need the key. That was quick. And we need to install the actual Google Cloud CLI tool. This is going to take a while. This took like 5 minutes at least on my machine. Now I've already installed it, so we don't need to do it on mine, but you would paste it in, hit enter, and install Google Cloud. Maybe grab a coffee because it does take a little while. Once that's done, gcloud init. This is how we get started with authenticating our Windows subsystem Linux virtual machine on our computer with our gcloud account. This should be pretty quick. Should be. All right, we must log in to continue. Would you like to continue? I'll hit Y for yes. It's asking us to follow this link in our browser. Sure thing, Google, whatever you say. I'll paste it in. If you have multiple Google accounts, make sure you choose the one that you've set Google Cloud up in. And then hit allow. Copy that code back into your CLI, right-click to paste it. It's going to ask us to create a new pick a project that we already have or create a new project. This really doesn't matter, but let's hit 3 to create a new project, and I'm just going to call it default 1, 2, 3, 4. We'll just let that finish. That's just setting a default project. Next, we need to enable authentication, like we were talking about before. We need to enable authentication from our CLI to our Google Cloud account. Is this frozen? No, it's just taking a while. Okay, there we go. It's done. All right, next, that command, auth application default login. We follow yet another code. New tab, paste it in. The same thing. This is going to allow the Google Auth library access. We'll hit allow, copy the code, and paste. We need to validate that the previous steps were successful, and we need our billing ID. We can do both at the same time by pasting in this command. And we'll need this value later when we edit our vars file, our variables for our Terraform deployment. We also need our username. And, oops, let me try that again. Copy and paste. Just so you don't get mixed up, this is a good way to validate. There's my account. And you'll notice it has an asterisk next to it. That's the account we'll need when we edit our vars file, which is the next step. Before we edit, though, make sure you're in the Cloudblock and then GCP subdirectory. That is the project that we cloned earlier. Whoops, and I just pasted or copied instead of pasted. There we go. We're in the GCP subdirectory. We also need to be in the GCP subdirectory in File Explorer because we're going to edit with Notepad. Copy this path. You'll notice it has the word chat in it, my name. That's because that's my Windows Subsystem Linux username. Yours is different, likely. You can figure out what it is by typing in who am I in Windows Subsystem Linux. All right, File, Explorer. In the address bar, paste in that address, change Chad if it's something else, and hit enter. And you'll see there the gcp.tfrs file. Double click it, it's going to prompt you what do you want to open it with, choose Notepad, and I've already done that. Here are the variables that we should change, and then here are variables that we probably don't need to change. Let's go over them. I'll scroll down to variables. The first one, this says is ph password. That's right here. I've already changed it to change me one. All right, make it something secure. This is just my demo. I don't care too much for mine. Next is your management CIDR. This is the IP address granted Web UI access and SSH access to your virtual instance in the cloud. It's also permitted, this is important, also permitted Pi-hole DNS access if the DNS no VPN variable is set to 1, and by default it is. That allows you to set your router's DNS server, your home, let's say you're at home and you've got a router that runs your network. You can change DNS there to your instance that we're going to create with Terraform, and you'll get ad blocking through Pi-hole. If this was not set to 1, if you had set it to 0 instead, you'd only be able to connect to your cloud services with the WireGuard client. Keep that in mind. All right, what else do we need to change? We need to change our SSH, and management CIDR. I've already done that. That's my IP address, don't hack me. If you don't know your IP address, you can figure it out easily enough. You can go to Google and type in what is my IP. And there it is, my IP address. And I've pasted mine in. Leave that /32. That's a CIDR notation for a single IP address. All right. SSH key. All right, let's go back to PowerShell. We can get our SSH key. We generated it earlier in the previous video, and we can get it with the cat command, squiggly line /.ssh/ again, id_rsa.pub. There's our SSH key. We don't need this little bit at the end. I don't usually include it. So I'm going to start from here, work my way all the way back, right click to copy to my clipboard. In between the quotes, I'll delete the default value. Now I just have the quotes, I'm in between them, and I'll paste. Hit home to go back to the front. SSH key is done. What else do we need? We need the GCP billing account. This is the billing ID for our Google Cloud account, and we got that from the command we ran earlier. Where is that command? Oh, right here. Highlight it, right click to copy. In between the quotes, we hit paste. And we need the same thing for the GCP user. That's my GCP user. I've already set it. Hit paste. What else do we need to change? We don't necessarily need to change anything else, but worth referencing. The machine type, this is the size of the virtual machine that we create. This is one of the smallest ones in Google Cloud, and it's part of the always free tier. So we're actually running this with, I don't think there's any cost, or there's very, very low cost, maybe a few pennies a month to run this entire project. And that's partly because we've chosen an F1 micro instance. It's pretty small, but it will run all of our services just fine. Also, the GCP region and zone, you'll want to look for a Google Cloud region that's closest to you. I'm on the East Coast, I'm in Florida, so this works perfectly for me, but it's worth searching around Google Cloud to see which region is closest to you. That's going to help with latency, right? And then finally, your DO provider. If we look at the diagram at the very top, that's this cloud over here, right? So your DNS lookups will go through WireGuard, through Pi-hole, through Cloudflare D to your DNS over HTTPS provider. There are many you can choose from. Pick one. I really like OpenDNS because it works. I've never had a problem with my DNS lookups, but there are some that offer different features. Some are likely faster than others, or maybe only available in certain countries. It's worth checking out and doing a little bit of research on. That's everything. A quick interjection, make sure you set an additional variable, it's now in the README, called WireGuard peers. That will generate however many you choose configurations for your WireGuard VPN. For example, if you've got at least 2 phones that you know will use the Cloudblock service you deploy, make sure you have at least 2 set. The default is 20. There's no harm in generating more than you need. I believe the upper limit is around 250. Thanks. I'm going to hit save because that is the next step. There it is. Edit the file and then save. Close it out. We're ready to deploy. Make sure you're in the GCP directory. Let me go back down, paste. We are. And then initialize Terraform. This is going to tell Terraform to install the Google specific modules and any other thing it needs. Everything's fine. That was quick. And now we'll do Terraform apply. This will tell Terraform to look at the project files in my project, all the Terraform files, figure out what resources need to be built, and it'll spit out a plan to us in the console, and it'll ask us if we want to proceed. We can see what resources it's going to create. So I'll hit enter. And there we go. There's a plan to create 27 resources. If you scroll up, you can see those 27 resources. For example, there's an ACL, access control list, for the bucket. There's the bucket itself. There's my service account. We'll hit yes or type in yes. We want to perform those actions. Terraform is now talking to Google Cloud and creating all those resources in the order we need, customized for us based on our vars file. It's going to take a little bit. Let's be patient. I'll be back when it's done. Okay, Terraform has finished up. We have some outputs at the bottom here. We can SSH to our instance. We can visit the Pi-hole web UI, or we can check out the WireGuard configuration files. What's important to note though, if we go down to our instructions, let's note the outputs from Terraform after it completes. We just did that. And then we need to wait for the virtual machine to become ready. Ansible is still setting up the services for us, especially right after we finish deployment. If we look, just to explain that a little bit, if we look at this diagram, you'll see there's Terraform and Ansible in the hexagon. Terraform creates all the cloud resources, like the network, the storage bucket, encryption, and the instance, the virtual machine that lives in the cloud. Ansible will configure the virtual machine. There's almost as much work for Terraform as there is for Ansible. So Ansible spawns as soon as the virtual machine is created, and it's running now. We can watch its progress. You scroll all the way back down. So here we go. Want to watch Ansible set up the virtual machine SSH in. Here's that SSH output. We'll copy it, paste it in. It'll prompt us, are you sure You want to continue. This is because this is the first time we're SSHing into this instance. We'll say yes. And we can tail the Cloudblock log file. I'll paste that in. Now, the log file might not be created yet. That's okay. That's because Terraform has to install, the instance has to install Ansible, and then it will start generating this log file. Yep, it's not there yet, but eventually it will be. Let's be patient while Ansible does its thing. You'll start seeing lines popping up as Ansible completes the installation. All right, Ansible has finished. We can see from the log file that failed is 0. We are good to go. And all of our resources have been created. We can now check out the Pi-hole web UI. Copy that, open up to my browser. Your connection isn't private. That's okay. That error message is fine. That means that we have a self-signed certificate, and you can see that there, certificate authority invalid. Our connection is still encrypted. So we'll hit advanced and continue. I'm going to turn off my dark reader extension. There we go. Let me expand that out a little bit. Let's log in. The password is the password we set in our vars file. Mine was change_me1. And we are logged into the Pi-hole. You can change settings as needed, though one of the settings I'll mention under DNS, oh, there it is. You'll see it on the right-hand side there, is an IP address, and it's set for both the custom 1 and custom 2 upstream DNS servers. That is our DNS over HTTPS container. Whoa, baby. Sorry, my cat just needs a little attention. If we look at the diagram, Pi-hole here in the middle talks to our Cloudflare D container before it talks to our DNS over HTTPS provider. You could change that setting, but you might lose or otherwise misconfigure DNS for the Pi-hole, so keep that in mind. Okay, and then finally the WireGuard configuration files. Those are available at this URL, which is our Google Cloud Storage bucket. Now, if you have a cell phone, Android or iPhone, a tablet like this iPad right here, you could have the WireGuard app installed on it and use it anywhere, whether you're at home, on the road, on public Wi-Fi, on your mobile service provider, your cellular network. What you would do is check out, oh, let me turn off my dark reader again. You would look at this Peer 1, this is infuriating. Okay, you would look at your peer1.png file. That is a QR code. So we can download that code or just click it and you can view the QR code there. If I had the WireGuard app installed on this iPad, I could open up the app. There's an option to scan a QR code. I'd put it up, my camera up, and scan it. And my iPad would be good to go, or my cell phone would be good to go. I can turn on the VPN on the cell phone through the app, and anywhere I go, my DNS lookups are done through the deployment we just created, and we're blocking ads. So we've got ad block on an iPhone, ad block on Android. A lot of devices support WireGuard. Windows supports it, Mac, Linux. On top of that, we don't necessarily need to use WireGuard if we're in our home network. If you remember, I alluded to the variable called DNS underscore no VPN, and it's set to 1 by default. That allows our home network to use DNS without WireGuard. We would do that by going maybe to our router and changing DNS settings to point to this IP address, the IP address of our cloud virtual machine. Okay, that is everything. The final piece of the puzzle is maybe we're done. Maybe we're done with this project. We don't want to deploy it anymore. We can destroy it the same way that we created it with Terraform. Let me log out, Control C to get out of tail. I'll exit the instance. And we can, just like we did Terraform apply, we can change that to destroy. Terraform is going to validate what resources need to be destroyed, only the resources that it created. It'll prompt us, and I can say, yes, I'm done with this demo. I don't need this project anymore. There we go, 27 resources to destroy. I'll say yes, and Terraform will happily delete everything for me. That's it, everybody. Have a great day. Take care.